And a pointer is just like pointing to some location in memory where a value is stored. And so memory in a computer is like, I've already explained this before, but I'll just say it again briefly. It's like a post office with a bunch of PO boxes, and each of those PO boxes has an address, and you can store things in each one of those little PO boxes. You can store a value in each one of those PO boxes, and the value, you know, that you stored in that PO box will have a memory address. Will have an address. Same deal in programming, right? That's kind of like the way memory works. It's just a whole bunch of different little slots, little cubby holes, a bunch of little post office boxes where you can store stuff, and every slot, cubby hole, post office box, whatever word you use, has an address. And so the easiest way to see this is just create a variable, a colon equal 42, and then print line. Let's print out that variable, and we run that. We've got the value both times. But if we use this ampersand right here, so that ampersand operator, and that's an operator. So if we go look at the Golang spec, and we look at the language specification, and look at the operators down here under the operators, we have one of the operators is that right there. Just give me the address. That's how you see the address in memory. So now when I run this is the address in memory where that value is stored, right? That's the address in memory where that value is stored. So that's one operator that we have to use to print out that variable, and we run that. We've got the value both times. But if we use this ampersand right here, so that ampersand operator, and that's an operator. So if we go look at the Golang spec, and we look at the language specification, and look at the operators down here under the operators, we have one of the operators is that right there. Just give me the address. That's how you see the address in memory. So now when I run this is the address in memory where that value is stored, right? That's the address in memory where that value is stored. So that's one operator that we have to use to see the address is the ampersand. And so just burn that into your memory right now. You know, here is the value, and what is the address? And what is the address? So use the ampersand, which also means and it's just like that phrase. And what is the address? So you put the ampersand and it shows you the address. So we could take that and we could also look to see some interesting stuff. So I'm going to copy all that. I'm going to change these to printfs, and we'll do %t here and a new line, and we'll pass in a. I'm just going to copy that one. That'll be easier. Just change that part and then get rid of this part. All right. So now if we take a look at this, the first one gives us the value and the address. Now we want to see the type of that value and the type of that address. And if we look at that, we see that the type of the value is an int, and that totally makes sense. But the type of the address is a pointer to an int, a pointer to an int. And this is a completely separate type than this. These are two different types, just like a string and an int, two different types, or a bool and an int, two different types, an int and a pointer to an int, two different types. You can't mix and match them. This is static programming, two very separate, distinct types. This star right here is part of the type. So that's a pointer to an int. And that makes sense because here's the address, and at that address, an int is stored. So we're pointing to a location where an int is stored. It's a pointer to an int. So you've got two things to remember. You have the ampersand, which gives you the address where a value is stored. And then when you are talking about that address where the value is stored, that is going to be a pointer to an int, a pointer to where an int is stored. It's a pointer to an int. And that is its own type. So if we had var b int, we could not assign assign the address to it. We could not do that. That's not going to work. It's going to tell us cannot use ampersand a, which is type pointer to an int, as type int in assignment. We can't do that. If this was a pointer to an int, no problem. And then we'll get an error that we didn't use b. So if we print out b, just take a look at it, we'll be able to see that that is the exact same address. So this is kind of interesting. Everything in Go is passed by value. I've said that before. Right? But now we're able to share addresses. We can say, hey, here's an address. This is an address where value is stored. That's kind of cool. All right. So the main thing I wanted to illustrate there was that we can't assign a pointer to an int. We can't assign a pointer to an int to an int. Can't assign a pointer to an int to an int. They're two different types. So this is the int. This is the pointer to the int. I'm going to take b, and I'm going to do a colon equal, and I'm going to assign a to it. So that's pretty much what I had before, but just short declaration operator instead. So now b is that address. What if I wanted to see the value stored at that address? There's one more operator that I can use, and that's this asterisk. And so if we come in here and look at the language specification, we see that the asterisk is also an operator. This asterisk right here is an operator. This asterisk right here is part of the type. Two different things completely. So it's the same lexical element, the same symbol, but they're used in two different ways. When you see this asterisk with a type, that is a pointer to that type, a pointer to an int. It's a pointer to where an int is stored. Okay, so when you see that asterisk there, pointer to an int. When you see it like this, I am dereferencing an address. So when I have an address, I could put another asterisk in front of it, and that's an operator, and that's going to dereference that address. What's that mean? Bam, 42. It gave gave me the value that is stored at that address. So this asterisk gives me the value stored at an address. Cool. You got a couple things that you're remembering right now that you're learning. Ampersand gives us an address, right? And with an address, that becomes a pointer to an int, or a pointer to the type, which is stored at that address, right? That's the value. So we have an int, which is one type, and we have a pointer to where an int is stored, pointer to an int. That's a completely different type. So we can take an address, we can get an address, I'm taking the address here, and once we have the address, which I've assigned to B, and we can see that right there, we can dereference that address and see the value stored there. So we could get the address with the ampersand, and once we have the address, we could get the value with the asterisk. Check this out. We could even do this. Give me the address of where the value stored at A, so that's 42. Give me the address there, and then dereference it. And then dereference it. I have no idea why. Whoops. I have no idea why that just deleted that. Start, and then dereference it. Run it. Waiting for remote server. Come on, remote server. Error communicating. Let's run it again. Cool. And so this last line right here, it gave me the address, and then it gave me the value stored at the address. So ampersand gives you the address, and asterisk gives you the value stored at an address when you have the address, right? You have the address, and you want the value stored there, gives you the value stored. Stored at an address when you have the address, right? That's what that asterisk does. So that's it. That's it. Those are pointers. And it's just, you store value in memory. Wherever that value is stored in the compiler, the computer just does that for you. You can see that address. If you have that address, like right here, you can then dereference that address and you can get the value. And if I wanted to, right, because right now, format println B and the address is stored there, I could take ampersand, I could take asterisk B, and I could set that equal to 43. So here's the address, and at that address, the value at that address, assign it to 43, and then watch this. And I print out A, and this A is now going to be equal to 43. Whoa, so why is A equal to 43? Because A is stored at a certain address, and I got that address right here and assigned it to B, and then B is address, right? It's pointing to the address where a value is stored. I said, give me that value, set it equal to 43, and then and print that value at that address. Like A is pointing.
¿Qué curso es el que escuchas? Un curso de programación en Go para ver qué es lo que dice y ver qué rollo. Pero pues está en inglés.
A is like the value stored at an address, and B is that address, and I said that value there, change it to this. And so A and B are both talking about the same post office box and dealing with the same values stored in that post office box, that memory address.
Es de un profe de la universidad. Pero pues ya está en por dos, lo estoy viendo en por dos y pues ya. Lo estoy escuchando más rápido.
All right, so just a little bit of review. You take an address by putting the ampersand in front of, value. And what's your address? And all you do is do the ampersand. And when you have an address, you can dereference that and say, give me the value of, what's at this address. Give me the value of what's at this address. Let me zoom in on that so you can see it. Give me the value of what's at this address. That's dereferencing. And then you can also do this, like the value at that address, set it equal to this. And then the last thing, which is good to know about, was here we have an int and we have a pointer to an int. Those are two different types, right? And a pointer to an int, this asterisk is part of the type, but this is an operator, right? When you have an address, that's an operator. And a pointer to an int just means that this is an address where an int is stored. We're pointing to an address where an int is stored. That's a pointer to an int. So there's a little bit of information, but all you got to remember is ampersand to get the address, asterisk as an operator to dereference an address and get to the value that's stored at a certain location, a certain address. And that when you have an address, the type of that is a pointer to whatever value type is stored, whatever type of value is that's stored in that address. So here we have a pointer to an int, and that's part of the type. I hope that makes sense. If it's the first time you're coming to pointers, that might be a little bit like, whoa, there's a lot. Just rewatch this video and hand code some of this out yourself. I put a couple of steps with explanations in right here, and you can walk through those. And I'll also put in code from video, right? Code from video will go right there. So I'll go get this code from the video, make sure it's all well formatted, and I'll put that right there so you can check out that code from the video. All right, so that's what a pointer is. And in the next couple of videos, maybe, we are going to work on them a little bit, and we'll see some of that in action. We'll talk about where to use them too. Those are pointers. They're pretty cool. So when should you use pointers? So pointers are good if you have a large chunk of data and you don't want to pass that big chunk of data around through your program. You just pass the address where that data is stored. And now all you're doing is passing an address. So that could save you a little performance if you're thinking about like, wow, this is a huge piece of data we're getting back in the database. All right, it's stored in memory. Now just pass the address around and use the address where you need it. Another way you can use pointers is if you need to change something that's at a certain location. You could use pointers. And so that's the other thought you might have. When should I use a pointer? Hey, you need to change a value. You could use a pointer and it's going to change that value at that location. So you can pass the address somewhere and then you can dereference that address and assign some new value there. And so those would be the two ways that you might use pointers. So now what we're going to see is we're going to see some pointers in action. We'll code something up. And the one thing I want you to take away from this is everything in Go is passed by value. So drop any phrases and concepts you may have. have from other languages, pass by reference, pass by copy. Forget those phrases. Pass by value. That is the only phrase you need to know and remember. That is the only phrase you should use. Pass by value. Everything in Go is pass by value. In Go, what you see is what you get. Look at what is happening. That is what you get. So just look. Am I passing a value or am I passing an address? If I'm passing an address, I got an address. Now I can change whatever's at that address. And don't worry about those other phrases. Don't even use them. Right? So wherever you're coming from, throw them away and just use pass by value. And when you have an address, you can reference the value at that address. You can change the value there.
Brian, saludos. Hola, hola.
Don't use other phrases to describe it, because everybody's got different definitions, and it just confuses everybody, in my experience, from what I've seen. So just remember pass by value. All right, so now let's create a function, and this will be foo, and foo will take in an x, which is an int. And it'll func.println x, and I'm just making this up, and it'll set x equal to 43, and it'll func.println x, and then it'll return nothing. It won't return anything. And so then up here we will have, we'll make this y, just so we can kind of go in order. And up here we will have x is colon equal to 0, and then foo, and we're going to pass in x, and now we're going to print out x. Cool. So x is 0. We pass x into here. It gets assigned to y. What you see is what you get. We're passing in the value 0. It's an int. It's assigned to y. We print 0 out. We say y is equal to 43. We print y out. We come back up here because foo's done. We print out x. X is still going to be 0. Right? So 0, 43, 0. Totally what we expect.
¿Qué pasa si le paso la referencia? Oh.
expected to see, except we have one print line there, and this one, 0, 43, 0, 0. That's not what I expected to see. Print line Y should be 0. That's right. And then print line Y here is 43, and the print line Y here is 0. Totally worked. Okay. Computer never lies. It always just takes a little bit of time sometimes to understand what it's doing. I don't know if that's true. The computer never lies. It just does what it's programmed to do. So the next thing we want to do is instead of, and I'll save this as step 1. Step 1, code. Step 1. Step 2, no pointer. Step 2, pointer. Step 3, profit. So now we're going to change this code, and I got the YV in there. That's the YV. Cool. We're going to change this code to take in a pointer to an int, which means that we now need to pass in a pointer to an int, an address, right, where an int is stored. And so now the type is pointer to an int. We're going to print that out. We're going to see an address, and then we're going to dereference this. And we're going to say the value at this address, set it equal to 43. And then we can print out that address. We can also print out the value stored there. So we'll just add these in here. So there's the address, and then the value stored there. There's the dereference, and there's the dereference. And we can print out here the value. You know, we'll put this one right here. We'll print the address where x is stored, and we'll also print the value at that address, right? So that's the, just make sure we're doing that the same way. So the address and the value where the address is stored. And then we could add a little bit of help in there if we'd like. And so we could do this. X before, X before, X after, and we could do Y before, Y before, Y after, Y after. And that gives us a little bit of a way to see it. Format it all and run it. So X before, it's at this address, and look at that address, right? That's the same address all the way through. And I'm going to change before to just before so that we have a little visual alignment there because we're human. Same address all the way through. That's cool. So we have x is equal to 0. We pass in the address right here. The address is received right there. And so this is the x before and the y, right? Same address, same value. Then we take the value at that address and we set it equal to 43. So the y after, same address, and now it has the value 43. And then the x after, foo is run, same address, and the address, the value stored at that address is 43. And so by passing a pointer to the type of the value stored at that address, a pointer to an int, right? We're pointing to a memory address where an int is stored, a value of type int is stored, pointer to an int. By passing in the address, we were able to dereference and say the value at that address, dereference the value at that address should be this. And now since x and y both are like dealing with the same post office box, one of them can change the value there, and that's what they both see. And so that's where like a pointer allows you to change, and you'll hear people talk about it as mutate the value. So can you mutate, when you want a value to be mutated, totally weird. Like programming sometimes it's like, why didn't you just say change, right? But if you want to mutate, if you want it to be mutated, then use a pointer. It's like, what are you talking about? If you want to just change the value at the address, change it, use a pointer. But mutated is a word that you'll hear people talk about when they talk about pointers. And so, you know, this is all passed by value. Look and see what you're doing, what you got. I'm passing in an address. I've got an address. Then I can dereference it, you know, and get the value at that address and do something with it. It's all passed by value. Passed in the value of an address, right? Before in the previous one, I was passing the value of an int, right? The value here is a pointer to an int. Since it's an address, you always pass by value. Whatever the value is, that's what's getting passed in. All right, so that's a good little example of how a pointer to an int allows you to mutate a value stored in a memory address. It allows you to, you know, pass a value into a function, change the value at that address, and everything that's looking at the value at that address sees the new value. Makes sense, right? So if that's a little foreign, code this one up yourself. Just kind of look at it and recode it and walk yourself through it as you do it and talk yourself through it. And then watch this video again if you really want to learn this. Let's make a video yourself teaching it. Upload it to Twitter.
Gracias, Chochi. Estoy estudiando para dar el curso de Go. Estoy en la sección de apuntadores.
And then tweet it and tag me in it so I can see it. All right, good on you. That's the next step in understanding pointers. Good on you. That's what the Australians say. I like that saying. Good on you. All right, there we go. When to use pointers. So now that you know about pointers and now that you know about functions and methods, we're going to talk about method sets. So we saw how methods to it. Those methods attached to a type are known as its method set, right? What is a set of methods attached to a type? That's its method set. And depending upon whether you use pointers or just, a type which is not a pointer, value which is not a pointer, it's just a normal type, not a pointer to some type, then that determines which methods attach. And so there's a rule for that. And if you go into language spec and you look under our types, right? Here we have types. We've learned about Boolean, numeric, string, array, slice, struct, pointer, func, interface, map, and now we're looking at method sets. We're not going to law this out. And the wording on method sets is a little bit confusing. Just a little bit, yeah, that's a little bit confusing. You can pause the video right here if you want and read through it, and then unpause it, and I'll kind of give you the lowdown on it, explain it. So here is my breakdown of how that works. So method sets determine what methods attach to a type. It is exactly what the name says. What is the set of methods for a given type? That is its method set. So a non-pointer receiver. Remember, we attach a function to a type with its receiver, and we'll look at an example of it right here. Right, so here we have type circle, and we are attaching to type circle the method area, right? And then down here we say shape interface is anything with this method attached to it. Type with that method attached to it also is of type shape, and then info takes shape, and we print the area, and we say s area, and we call it. And it runs that function, and then down here we create a circle, and the circle is, I did that one really shorthand, so ideally I should have done it like this. Radius, sometimes our bad habits, we get caught with our bad habits, there we go. But that looks so clean, just right, the 5. It's hard, that's pretty clean. There we go. I'm going to leave it. And then we pass that circle into info C, and it calculates the area. And so this method right here, area, is very much attached to type circle with this receiver. So type circle, the value is just a regular type. It's not a pointer. And this is just a regular type. It's not a pointer for the receiver. And so that's where we come into this deal here. So non-pointer receiver, like we just saw right here, this is a non-pointer receiver. Works with values that are pointers or non-pointers, okay? A pointer receiver only works with values that are pointers. So you can see that here, a pointer receiver only works with values that are pointers, but a receiver which is not a pointer works with values that are not pointers or pointers. And so I have examples of all that code right here, and this last one doesn't run. So we saw the non-pointer receiver and the non-pointer value. Here we can have a non-pointer receiver and a pointer value. So non-pointer receiver is going to work with a value that's a pointer or not a pointer, so this will run. So we can just come in here and we can say, hey, make that value a pointer, and it's still going to run. That's like the second case right there. A pointer receiver and a pointer value will run. So we can come in here and we can say, hey, this is a pointer receiver. It's going to attach to any type. That's a pointer. So value of a type, pointer to a circle. And if we look up the type on that, we'll see this is a pointer to a circle. Don't believe me. Believe the Go compiler. That's why I love teaching you this %T format printing right out of the gate, because we lean on it when learning the Go stuff, right? So that's a pointer to from package main type circle, and so we have a pointer to type circle, and that's going to work, right? So when we have a receiver that's a pointer and a value that's a pointer, that totally works. And this is the example we just did right there. So we have a receiver that's a pointer, and we have a value which is a pointer that works. But this last one does not work. We have a pointer receiver and a non-pointer value. So let's take this pointer out. We have a pointer receiver right here and a non-pointer value. We run that, boom. Cannot use C, type circle is type shape and argument to info. Circle does not implement shape. Circle does not implement shape, right? Does not implement the shape interface. Area method has pointer receiver. Area method has pointer receiver. So that's what a method set is. And so there's just like that one instance where you got to watch out for. If you're using pointer receivers because, hey, I want to be able to change things, then you got to use pointer values for that method to be attached. If you just use regular receivers, then you could use regular values or pointer values for that method to be attached. So pointer receiver and a non-pointer value, a pointer receiver and a non-pointer value, that doesn't work. That doesn't work. I'll zoom in on that so you can see it. So that is exactly what this method set stuff right here says, but that's a little bit confusing. I'm not even going to read it. I'll let you read it. But what I shared with you is my synthesis of that right there. And I actually had to write the code out and work it out to prove it to make sure like that was the correct understanding. So that's what a method set is. And that's more of an intermediate to advanced topic, but I just wanted to be on your radar now that you know about methods, you know about pointers, and you might be thinking pointer receivers so that you can change values and things like that. Be aware of method sets and know what those are. And just like bookmark this because you'll want to come back to it. At some point you'll be like, oh, what's the method set? How does that work? All right, that's method sets. All right, so now we're in a hands-on exercises, Ninja level 7. And this first hands-on exercise, I want you to create a value and assign it to a variable, and then print the address of that value. value. That's it. Super simple. So pause the video, go do that, and when you're done, come back and unpause the video, and then watch the solution right here. I'm going to create a variable address for this value ampersand. Hands-on exercise number 2. It's got a little bit of
Josué Rojas Paredes, saludos, saludos, pana. ¿Cómo vas en Go? Bien, ahí vamos, ahí vamos. Aquí estudiando.
the curveball in it.
Se cocinará curso. Así es, se
Make
está
sure you hear
cocinando
change.
curso. Primero tengo que dominarlo chingón para ya después enseñarlo de la manera más sencilla que se pueda. Según yo así se hace. Vamos a ver qué es lo que dice este pana.
To Miss Moneypenny. Value that pointer to P, or, and I'll comment this out, we could do it like this, a pointer to P, or dereferencing P, so what's at this address, then give me the value there, and first, and then we'll set that equal to Miss Moneypenny. Miss Money P, we'll call it Money P so we can just see the difference. All right, let's just make sure I have that right in the notes, I have those in the correct.
Eso no lo sabía.
All right, let's just make sure I have that right in the notes, I have those in the correct place. I do, I was just checking to make sure it's dereference the value at this address, give me the value at this address, or whatever. So dereferencing that address, give me the value at that address, that's the right way, and then dot that field. Okay, let's run it and see what happens. Format and run. P first, undefined type, pointer to person has no field or method first, that's because I changed it to name. You probably saw that and you're like, name, it needs to be name. All right, so we create a type person, a value of type person, we assign it to P1, we print it out, we get James Bond, we call change me, we pass in the address, this takes a pointer to type person, a value of type, pointer to person, type pointer to person, right? So value of type pointer to person, and then we can just do, hey, that person, the name is equal to this, and that gives us Miss Moneypenny, or if we wanted to, heck, we could run them both. We could leave that uncommented and run it, and it changes to Miss Moneypenny, and then changes to Miss Money P, and that worked also. So that's from the language specification. There are some nuances, right? I put that into the outline. That was a little bit of something that's good to be aware of, something you probably would have figured out if you came across it, but just wanted to make sure that I pointed it out because it came to mind for me. All right.
Excelente. Perfect.
Sweet. That's hands-on exercise number 2. Taking an address, understanding like the pointer to some type, sort of pointer to an int, pointer to type person, and then also understanding that the asterisk is, dereferences an address and lets you work with the value at that address. Those are the important things to understand about pointers. That and method sets. If you use a pointer receiver, then it can only be used with values of type pointer. That's also important. That's hands-on exercise number 2. You've now reached ninja level number 7. Congratulations.
Perfecto.
So now you know enough about the Go programming language to start working with some of the code from the standard library more easily. We might have been able to start before, but before you knew funcs, before you knew pointers, that could throw you off, before you knew methods and make it hard to read the standard library. So now what I want to do is just take a couple of examples and look at how we use the standard library to start integrating that pre-written code into our applications. And so some of the things that we're going to look at might be, like we're going to look at marshalling and unmarshalling to JSON. That might be a little bit...
Ok, va. Hasta ahorita aquí voy a dejar el video de hoy, este stream de hoy. Espero les haya gustado y recuerden, rómpanla y síganla rompiendo. Adiós, gracias por ver. Como ya saben, hacemos streams diarios, así que también tenemos cursos. Aquí se los voy a poner. Cursos. Adiós, Chochi. Adiós, Brian. Gracias por estar en el directo. Ahí están los cursos, ya se los dejé. Espero les haya gustado y recuerden, cuando salgan los cursos, ustedes van a tener descuento. Saludos, Andy Rus. Bye bye, cuídense. Los quiero demasiado. Gracias por estar.